everyone. Thank you for joining us today. We're going to do today a joint meetup between Madrid Youth and Madrid GUI user group. I'm from Madrid Group. And today we have here Milen Dyankov. It's a developer advocate for AxonIQ. So he's going to talk about demystifying events-related software concept and methodologies. And basically that's it. At the end of the talk, please don't leave. We are going to raffle a few things, and we will have some pizzas and drink. So that's it. I hope you enjoyed the talk. Thank you.
Hello, everyone. Welcome. I was going to say something. I'm going to embarrass myself. Yeah, I took a Spanish course for 1 year, and but that was 10 years ago, so I don't want to know how good I'm at. Thank you again for coming, for being here tonight. We'll talk about event stuff. After a while, I don't know how many of you do talks, but yeah, this like, oh, I'm going to this method. Then obviously it works this way. So after a while, I'm trying to
use this, please.
Okay. Here you go. Is it on already? Yeah.
Yeah.
Okay.
That was it.
Yeah. Well, what is it? A talk without technical difficulties. Hey, anything else you want me to change? Please don't say quotes.
Maybe later.
Okay. Good. Can you hear me now? Thanks. So hello everyone online then. I totally forgot we are live with on some, I don't know, channels online. So where were I? I was saying something. Oh yeah. So one thing I like to do with talks after a while, try to think and reason about like how did it go? Like whether the message I was trying to kind of analogy for the talk, and the analogy for this talk I came up with is an epic fight between two submarines. And that's basically how this talk goes. We'll talk about the surface. My hope is you imagine the epic fight happening behind the slides, right? So, demystifying event-related software concepts and stuff. That's the journey we're going to go on today. And as with every journey, it starts at the door. So you have a door. Probably shouldn't walk here so you can see better. You have a door. It has an ID. It's 28 in this case. And it has a property of color, and it is yellow. Oh, no, wait, it's red. Now, does that change bother you? Is it yellow or red now? It should, because now the question that should pops up in your mind is like, why it is red? Or when did it become red? Why he said yellow? And who caused it to become red? Right? All these questions, or what was the color before, if you will, you can't answer these questions if all you have is the state as of now. You can think of it as a database. You get a database, you have a record in that database says ID 28, color yellow. Boom, color is red. And the fact that it was yellow is gone forever, right? And we design systems this way all the time, and no one ever considered this being a problem, right? Except when they need to answer those questions, then it's like, well, you should have told us. What about changing that concept? What about saying, let's store the change instead of the state? Let's store the fact that Joe painted the door 28 red yesterday. Now, if you have a place to store that event, because that's something that has happened, now then you can answer those questions very easy. It's red because it was painted, Joe painted it, he did it yesterday. it gets a little trickier with what color it was before, because you probably don't store that. But then again, if you store all the information this way, you probably have historical records, and you can go back in your records and at some point in time figure out there was a event saying a yellow door number 28 was installed, and there was no other event between the last one and this one, so the previous color obviously was yellow. So if you store data that way as events, then that gives you a lot more possibilities to reason about things than if you only store state. Yet still we do store state because that's what they told us it's cool, and so we keep doing it. Okay, I mentioned the word event several times already, so let's try to define what an event is, because right now we are talking about things that probably everyone has different definition for. So event is a notification that something has happened, and that's all an event is. It notifies you about a fact. Now, you can say, well, yeah, that's pretty obvious, but one thing you may not realize is that's very powerful because events are immutable. If something has happened, it cannot unhappen, right? There's no way you can make it not happen, right? We're talking about immutable things. You can do something else may happen that reverts the state back to what it was before, but that's another thing happening. Like the fact that something occurs it's a fact. You cannot change that. It's an immutable thing. And as developers, we really like to talk to deal with immutable things, because then we don't have to worry about things suddenly changing and we need to react to that some way. Or as Martin Fowler puts it, when you talk about events, then you all of a sudden have a way to make a change, a first-class thingamajig. You have a way to represent a change. Something has transitioned from one state to another, and now your application already knows about the change, not what the state is after the change, right? So you now have a way to represent a change in your application. But when you want to build these applications this way, what you need to do is you need to start designing them this way. And so there are a couple of techniques that allows you to driven, and we'll come to that term in a sec, applications. And one of them is event storming. So event storming is an idea that you can model a business process and actually discover the business processes by using events. Essentially, okay, so I'm gonna just go to. It essentially works like this. It's a huge, giant nodes, and what you try to do is you get everyone together, right? And you try to reason about what may happen in a system, right? Things like this can occur. By the way, there are seats here and here, and if you just don't want to stand. This is an approach that Alberto Brandolini introduced several years ago, and basically it tries to get the people in the room who have knowledge about the system. Those are not only developers; those are subject matter experts, perhaps business people, perhaps maintenance people, whoever is interested or has knowledge or has to interact with that system. It's to get in the room and they start telling that this can happen, this can happen. And now when you know something can happen, you start reasoning about why, like who is causing it to happen. And when it happens, who's supposed to react to that? And then you build the entire system around those events, around the changes that can occur in a system. Another approach to design systems this way is called event modeling. And event modeling is promoted as a blueprint for a solution. Now, you may hear people arguing that it's essentially a better version or newer version of event storming, but it's Adam Dimitruk would disagree as the guy who actually introduced it several years back. Adam's approach is, let's put all the events on a timeline. Roughly, we know which events can happen earlier in the process and which can happen later in the process. So I suggest we put all the events in a timeline, and then we design the process around those events. Like, okay, when this event happens because of, and there is another component that's actually causing this event to occur. And then when it occurs, there's another component that needs to react somehow, right? And so you basically model the system around that timeline of events. I'm not going to get to many details in. Just want to mention it. If you want to have more information, please go information online. The approach that Adam suggests to take has the that we treat that central line of events as the source of truth. That everything that can happen is just helping components that help you design the system. They actually do and workshops, and during one workshop they were trying to model a zoo this way, and while they were doing brainstorming they discovered this event. Now honestly I have no idea if that's for real, but he tweeted it, so I like it and I thought I'm going to share it. The point in that is, though, when you start designing systems this way, you free your mind to think about things that you think about otherwise if you're so focused on just code and architecture. All right, so things come across your mind or someone's mind that, hey, this may happen, and what do we do if it happens, right? And sometimes it's like, yeah, well, forget it, we're not going to deal with that. And sometimes it's like, oh man, we probably would have forgotten a significant application feature if we didn't thought about this, right? So designing systems from events actually allows you to do more in terms of better, how to say, handle the problem space, if you will. And so there we are with the event-driven. What is it then, an event-driven application? Well, let's go to the nutshell first. So we have this thing, event. It's a notification that something has happened. So someone is producing that notification. And we'll call that someone a producer. And someone is supposed to react to that notification, supposed to do something with it. And we call that someone a consumer. And now I'd like you to think about roles and not actual components. Right? That's not Java classes or objects or anything concrete. It's the role, and a single component in a sense of a like Java class or an application can be both a producer and a consumer. Those are the roles they play in the application and not the actual components. So the producers are the ones that notify that something has happened by sending events, and the consumers are the ones that are reacting to those events. But how do we get the events? Like how we get the event from producer to consumer? Well, we typically use some sort of message routing system. And I'm deliberately calling it a message routing and not event routing system. And it will be clear why that is later on in the talk. But let's assume we have some sort of message router, because events are essentially messages, right? So that thing in the middle knows how to transfer a piece of data from a producer to a consumer. There's enough people in this room for someone to be thinking right now, yeah, I know, that's Kafka in the middle. No, don't raise your hand, but I know you're here. So yeah, Kafka can do that. But not only Kafka can do that. We are just talking about message routing systems here, so pretty much any message router out there would do. So that's the nutshell of the nutshell of event-driven. But event-driven is a few more things. And in the recent year, it's more and more a buzzword. And I don't mean that in a bad way. So people say buzzword typically because they want to make fun of something. I mean it in a positive way, in a sense that this is how people look for things online. This is how people discover it. If you build software that is event-driven and you want to send message out there, that's probably the word you would be using. because that's how people find you. And that's the thing that people use in all kinds of product pitches and all kinds of product commercials, if you would, descriptions. Hell, we use it. If you go to the Axon framework, it's in the first sentence. It says that we build whatever evolutionary event-driven blah, blah, blah thing, right? So it is there. Be aware that it is a marketing term as much as it is a technical term, right? And feel free to use it in the marketing sense. I don't think there's anything wrong with that, for as long as you can make the distinction between event-driven as a marketing and event-driven as the application architecture style, because those are not the same thing, right? So another thing event-driven is, it's a false claim. And the reason it is a false claim is because it suggests that the events are the driving factor of the application. Now, everything that has happened in that application is because of the events. But that's actually not true, because we already said that events are just notification of the thing that has happened. So it can't be that the notification is causing things to happen, right? What is causing things to happen is decisions. At some point, someone or something makes a decision. That could be a person, that could be an artificial intelligence, that could be an if statement, that could be whatever else. At some point, there is a logic in the application that based on some data makes a decision, and that's the driving factor. That's what drives the system, that's what decides what's going to happen and what's not going to happen. And notification of that is what we call event. So events are just aftermath. They just carry the news, right? They don't drive anything, right? So every time we say event-driven, be careful to not fall in that trap that, oh my God, events are the driving factor. No, they're not. They just messengers. That's all they are. So yeah, another thing event-driven is, it's a polysemy, or it is a lexical ambiguity. And if you don't trust me on this, there are two ways you can easily prove this. Start talking to someone sitting next to you. Let's do event-driven. They go say, let's do event-driven, and then write it down like independently and compare it. 99.9% chance that you will be talking about two different things, right? As a matter of fact, there's a very good talk by Martin Fowler. It's called The Many Meanings of Event-Driven Architecture. If you want to dig into that topic a little bit more, he goes much deeper in those different ways of doing event-driven than I would in this presentation. But the point here is, don't assume that just because you're going to say event-driven to someone, that someone is going to understand the same thing that you have in mind by using that word, because probably chances are most likely they will be thinking about something else. So I'm going to touch base on two things here, two approaches to do event-driven architectures. And the first is event. So notification is essentially sending a short message to some other systems or some other components that something has happened, right? And it's basically like with all events, that's by the way true for all events, we don't expect any response. Notifications, that they just go out and someone may do something about them, may not, but the outer of the notification typically does not expect any response, right? That's how notifications work. So we publish those events, some other components subscribe to those events. We can argue whether the order is significant or not. In a lot of cases, it's actually not, but sometimes it is. But the event notification has the crucial feature that it works like the notifications you're probably familiar from LinkedIn. How many of you on LinkedIn? Yeah. Have you seen that? Like someone on LinkedIn did something with your profile. Thanks, LinkedIn. It would be nice if you tell me who, when, and why, right? But no, they just tell you something happened. And what you need to do is you need to go on LinkedIn and then politely ask LinkedIn to tell you more details about who did what, right? And this is essentially what event notification is. It just sends you things like something happened, and if you want to know more, you have to go back to the originating system and tell tell me what happened. Give me the details, right? And so it has the disadvantage that you always have to do this back trip. To mitigate that, what you can do is event-carried state transfer. Now, event-carried state transfer is basically collecting all the data that the potential consumer may ever need and send that as part of the event. And it kind of, mailing someone a zip drive or something, right? It's here it is, all the data, do whatever you want with it, right? So that is beneficial because now the consumer does not need to go back and ask you. Supposedly, all the information that the consumer needs is already in that message, in that event, and they can do whatever they want with it. Now, though, you have data in two different places. You have data in the producer, you have data on the consumer side. And welcome to the world of eventual consistency, right? We all know the fallacies of distributed computing, I hope. Right? So everything's great while it is great. And when errors start happening on the network, then things become trickier. So event-carried state transfer basically is this. You send all the data, and the consumers are making a local copy of that data. Now, it doesn't have to be exact copy. It could be data that's transformed in some way, or stripped from the original, only extracted bits and pieces that are important for the consumer or whatever, but it makes a copy and stores it locally so it can operate on that data, so it doesn't have to go back to the producer and ask them. So that brings us to the question, where is the source of truth? Like, as I said, if those two data sources are in sync, great, but what if they're not? What if you have two systems now, or two components, that claim two different things? One said the customer paid the invoice, the other said they didn't pay the invoice. Who is right? Right? It all of a sudden becomes a problem, because for each pair of components that interact with each other, you have two sources of truth. You have the one on the producer side and one on the consumer side. And it's next to impossible to make a decision which one is lying, because, well, you do there lots of ways of tracing and monitoring and digging into logs and whatnot, but it's not something that your application can do. Your application most likely will be impossible for your application to auto-recover from a situation like this. It will require your human intervention. Right? And that is because we have two sources of truth. With event notification, we don't have that problem. We only have one source of truth over there at the producer side. Everything this guy needs to do, go ask first, right? But with the event-carried state transfer, you do have these two sources of truth. Then you need to figure out which one to trust. So let's try to mitigate that. Introducing event streaming. So the idea of event streaming is, what if we extend our message router and add persistence layer to it? Let's store every single message that goes through this router in what we will call a stream of events, right? Now, when we have this persistence layer there, these guys here, the only thing they need to do is track where they are in that stream. How many, up until which message they have processed. And then they can disconnect and reconnect and appear and disappear. And every time they appear, they can say, oh, I've read to message X. Give me the messages after that. And they just read the stream, right? Anyone? Kafka fans? Yeah, Kafka can do this, of course. But again, let's talk about the source of truth now. So there's actually, if you introduce event streaming, I mean, it changed nothing if you only do event notification. It's just a different way of delivering messages. You still have to go back and ask, so that's boring. But it changes quite a lot when you do event-carried state transfer. And the reason is, now this local copy of the data essentially becomes a kind of disposable data, or a cache, if you will. Why? Because every time you are in doubt whether that data is correct or not, you can just throw it away, go back to the event stream and read the event stream and rebuild that piece of data. And you can do that at any time, right? So now you've got rid of the source of truth per component, but you still have two sources of truth. The one on the producer side and the one in the message router. And yeah, you will find articles online that will tell you that this is how Kafka does event sourcing. Quite a lot of them recently, actually. But that's not really what event sourcing is. Event sourcing goes one step further. And the idea of event sourcing is to actually have a single source of truth. And we do this with event sourcing by getting rid of the data on the producer side as well. Ooh, now I see scary faces. Yeah, like how our producers can emit any events if they don't have any states of their own? Like that sounds like impossible. Well, take a step back. Now let's ignore roles for a moment and pretend those are Java classes. Let's say that box over there is a Java class. So what happens normally, traditionally, without event sourcing is you instantiate that class somehow, create a new instance of it, right? And then you have some automagic JPA or whatever technology that goes to some database, reads some records from that database, and sets some fields in that class. The fact you don't do it manually does not change the fact that there is some technology that you use behind the scene that does exactly that, right? Well, what if instead of going to a database and read and do this ORM mapping and stuff like that, what if instead you just go to the event stream and say, hey, I am here, I'm this component, give me every single event that I have produced in the past. Boom. Now you read the very same stream that the consumers read, and you can reconstruct the state of that component from the messages that that component sent in the past. So if it's a new instance, never send any message, that's it. Nothing happened, right? But if it's already sent a message saying the field number, the field name, blah, 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 was updated, you read that message back and say, oh, I need to update my field. So essentially, you're rebuilding your state from the past events, much like you would do it with from a database or whatever your storage traditionally is. The tricky part is you need to be able to go and read only those events that the component itself has produced. You don't want to read the whole event stream because that would be highly inefficient. And that's essentially what event sourcing is. You have a single source of truth, one place where everything that has happened in the system ever is stored. And you know exactly what happened when, by who, and whatnot. And now even your producers and your consumers can build their states and react to events from the very same place. And this is the place that contains that data is what we call an event store. And this is why you would need something that is efficient that it can efficiently provide the functionalities that these components need. Now, typically that goes very well if you do domain-driven design, because typically those producers are then aggregates and the DDD lingo, and those on the other side are just components that react to events. You can do that manually. You can do that with a message router like Kafka, and you can store that in some SQL database or NoSQL database or document database or key value or whatnot. The problem is it will never be as performant and as efficient as a real event store. And I'll go a little bit through the features of an event store to explain why that is. First of all, an event store, so any other solution out there, SQL, NoSQL, key value, whatever you deal with, they are designed to do multiple things. they must allow you to modify data. They must allow you to update and delete and insert. And for event store, those are no op. You don't do this with event store. The only thing you do with event store, you append events in the end. We know events are immutable, so and we know they cannot unhappen. So we never delete an event. We never insert an event between other events, right? We never change the content of the event. So those are things we don't have to worry about. The only thing that the functionality we need to support is append new events at the end. That is a significant performance optimization versus any other solution out there, because you don't have to worry about those things. You can optimize, and you can optimize a lot. The other thing that an event store needs to provide as a feature is a full sequential read. Any component should be able to go to the event store and say, give me all the events from the first to the last. I don't care how many they are. I just want to read them all, right? So that is probably doable, but if you want to do that with a traditional database, that probably means you have to store all the events in a single table, or you have to do table joins, which is probably not very efficient, or with NoSQL, there are challenges. The other thing that event store needs to do is it's supposed to do to allow the consumers to replay events. So we set a consumer at any time can say, I don't trust my local state anymore, so I'm just gonna throw it away, and I want to rebuild it from the events that I was subscribed to. Well, that means that there may be trillions, zillions events in the event store, but that component only needs the ones that he's subscribed for, right? So the event store should be able, in an efficient way, to deliver only those events that are of value to that component, and not deliver every single event and let the component handle, oh, I care about this, I don't care about that. I care about it. The performance here, the performance optimization here now is on the event store and not on the component handling it. From the aggregate or producer perspective, it's a little bit different thing that you need. You need to be able to ask the event store to give you the events that you have produced in the past. So it's kind of similar with replaying, but it's from different perspective. It says, like, I don't care about other events. I only care about the events that I have produced, right? So again, the event store should be able to do this in a performant way without spamming you with other events that can change your state in undesirable ways. Another feature that an event store needs to have, and initially it feels like it's a nice to have kind of thing, but if you do a serious production enterprise systems, that's probably the key feature you want to have. That's snapshots. So when I say lots of events, that depends on what you understand by that depends on what's your experience. Like for some people, 1,000 is a lot of events. For some people, million is a lot, and for some people, I don't know, 10 zeros after the digit, the one is still not a lot, right? That depends on your system, but whatever is your definition of a lot, one thing does not change, and that is it's only gonna get more. Because we always append, right? We never delete, we never do anything that reduces the amount of event. And so with time, no matter what your system is doing, with time there will be too many events. And it's going to take too long for a component to go and read, even if it's reading only its own events, right? It can still have millions, tens of millions, hundreds of millions, or whatever amount is a lot for you. And it could start taking a second or two, a minute or a month to load the state, right? So what you want your event store to provide for you is a snapshotting, so that you can tell the event store, hey, event store, here is it. Every X event, or every so many days, or every time the free disk space goes below that threshold, or whatever the rule is, right? Make a snapshot. And making a snapshot essentially goes, okay, I'm going to build the component up to this state. And if the time is right to do the snapshot, I now have the state of the component. So I'm just going to store that state, right? And then goes again. And so if you, for example, configure your event store to do a snapshot, let's say every 100 events, what you essentially guarantee yourself is that you would never ever read more than 100 events to reconstruct the state. Because what you would do is you would go to the latest snapshot. Well, the event store is going to do it for you. You're basically going to say, give me everything. And the event store is going to go, oh, here is the latest snapshot. And here is this up to 100 events that has occurred after that, right? So if event store can do this for you, you essentially, no matter how many events are in there, you're saying that at any time you will not process more than 100 or more than whatever your, or more than the last 3 days, or more than whatever your rule is, right? So in large systems with handling lots of events, that's a key feature to keep the performance on the same level over time. Another thing that you would want your event store to do for you is to provide you the ability to do partitioning and archiving. I'm not sure what types of systems you're dealing with, but if you ever done something like, I don't know, accounting, for example, invoices and stuff like that, you would know that there's a reason why they close years, right? They don't want the invoices from the last 5-10 years to be around when they do daily operations. But that does not mean that they delete all these invoices and forget they ever existed. They're still there, but it just offloaded somewhere, so they don't go on the way on a day-to-day operations. But then if you need to, you can still do some analysis. Say, okay, let's grab all the old data and do invoice analysis for the last 10 years, right? But that is what partitioning and archiving is. You have the ability to get some data that you don't consider important on a day-to-day operation, as that's legacy or old or whatever, and offload it on a cheaper space perhaps, right? So you don't have to pay the price of holding that data, or it doesn't get on the way while you're building while you are doing the important stuff. And so that's essentially what an event store needs to provide you with. So you can obviously do this, with the existing solutions, as I said earlier, but there is the reasons event stores exist is because none of the other solutions actually is able to provide that level of the level of performance that you would need from an event store. So we talked about a bunch of different event-driven techniques. Are we event-driven yet? Well, as I said earlier, you can claim you're event-driven at pretty much the moment you start sending something to someone, right? You can call it event, and you can call yourself event-driven. So event-driven has many names and many definitions. So yeah, sure, we are. That said, there are two things that I want to bring your attention to, because I think that is one of the most overlooked part when we do event-driven systems, or should I say when we overdo event-driven systems. And that's what I call passive-aggressive events. Now, you probably have no idea what I'm talking about. So let's go with an example. Here is an event. The event says Joe ordered to paint door 28 in red. Now, think about that. An event is a notification of something that has happened. So what notification this event carries? It notifies that someone ordered something. Is that what you care about? Is someone is going to actually react to this? Oh, someone ordered something, fine, good to know, Joe, right? No. And the reason, and why we do this though, because we at some point got together and decided that we're going to do an event-driven system. And because we decided it's going to be event-driven, then everything is now events, right? And so we have this event, which is not an event at all. That's essentially a command. That's a direct request for an action targeted to a particular actor, probably. That could be a person, that could be a department, that could be a software system, that could be whatever else, but you definitely, like, transition that, revert Conway law. Like try to, Conway's law? Okay, the Conway law says that you're doomed to design system the same, to design the system in a way that represent your company's organizational structure. So whichever way your company is organized, that's how you design software systems. If you reverse Conway law, let's try to do this in the other way around. Imagine that in the real situation. Like in this, we are the same company here, and he's the boss, and he goes, and he wants the door painted. Would he be standing here and telling everyone, "Hey, I'm ordering to paint the door"? And you were like, "Yeah, go ahead, order yourself," right? No, that's not how it works, right? He will find the person or the department or the group of people that are responsible for performing that action, go straight to that group of people or that person and request to do something. But most importantly, it would require a confirmation, a yes or no at minimum, right? That if you ask someone to do something, you at least want them to acknowledge, right? And that's not what we have with events. Event, we said already, there's no confirmation, there is no response. You just tell the world something has happened, right? So that is how problems start to happen. Now you start thinking about how to design things that are not events to be events, because we decided we're just going to be using events. But that's not even that terrible. Let me give you another example. Joe asked, what is the color of door 28? What is that notifying you about? Hey, Joe has a question. Good, Joe. Yeah, right. Again, it carries no value because that's not an event. That is a query. That is a request for information. And we said events have no response. Well, guess what? In this case, the only thing you probably care about is the response. Right? If no one answers that, who cares that you want to know? Right? So we have masqueraded a query, a request for information, as an event. Now, picture how you're going to do this with an event-driven system. What you like with a topic or something. So what, you're going to send an event on a topic that says someone is asking something, right? And then how are you going to handle the responses? You have probably another topics where someone responds, and then you have some sort of correlation IDs, right? Been there, done that, right? And then people start complaining event-driven systems are hard. Yeah, they are. Let's make it more hard. Let's say that Joe asked about all doors. Now go figure. Like who knows which color of which door and how this response is being delivered, and all of a sudden you have messages flowing left and right, and people saying like, man, this event-driven stuff is like nightmare, right? Just because we have the wrong concept. We try to fit things into events when they are not events. So how can we handle this? And this is why I initially said we're dealing with a message router and not an event router. Because when you're dealing with messages, you can represent every event as a message. But a message does not have to be event. It can be something else. And we can design different types of messages. So we can design a type of message that is a command. And that type of message has different logic. It does not go to everyone. It goes to a component that knows how to handle a command. And it may have a response. It may carry an information back that acknowledges or denies or confirms or rejects executing the command. We can define another type of message, and we call that message query. And now that has a different semantics. It can go not to one, either to one or many components, because there may be many components that know the answer of the question. Right? It can perhaps merge those answers into a single response. But the most important part of that flow here is that whoever is sending that message needs to get a response back. Right? That is the crucial part here. We are asking for information, so we need to get this information back. Whether that's happening synchronous or asynchronous, that's a different story. Right? But the intent is there. there has to be a response to my question, right? If you've been paying attention to this carefully and you've read this architectural patterns, you're probably now thinking, yeah, he's talking about CQRS. Yeah, that's a spot on. So let's have that out of the way. So you know what CQRS is for those who don't. So CQRS is the idea that we have distinct models for commands and queries. Now, when Greg Young introduced this several years back, the original idea was to basically have different objects. So you have one object that only contains operations that mutate states. So every time you have to do an update, like change a value or calculate something and store it and whatever, every time you mutate something, that's your command component. That's a command object where you put the method doing so. Every method that returns a result that you just ask, tell me this, tell me that, give me the value of this, blah, 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 that's your query object. And that was pretty simple. That was the simplest idea at the time, like just have two different classes to represent the write part of the thing versus the read-only part of the thing. Now that concept has evolved since then, and we're now not talking about two different objects, but talking about different models. And the reason we talk about different models is, again, how we design systems. So you've been there probably more than once, and you know how it starts. You have the thing. That's probably a real thing, something out there, right? Or is an idea in your mind. And what you as a software architect or developer or engineer is doing is trying to map that real thing to a software concept. So, okay, we're gonna have, this is gonna be an object, it's gonna have this field, right? We do this all the time. How many of you, just out of curiosity, at this stage, how many of you are already concerned about how your database is gonna look like? Okay, you don't have to raise your hands, I know you do. That's how we do. That's what we try to do. We try to create the perfect model. And the perfect model, we have the model that represents the real thing, but it also represents how we store it in the database. It also takes into account how we're going to change things, and it also takes into account who's going to be asking about things. So there's got to be one model that serves them all, right? And that's next to impossible to do. And at some point, we are super happy that we are very close. And yeah, we are happy for about a month or two before we discover how wrong we are. So the idea here is, let's do one model. When we model changes, let's have a model that's optimized for doing exactly that. And that's the only place where we change things. Every command, every request to change something goes there. And that model, however we design, as ever changes the system, but that model. And that's one model, and it's what did isolate in bounded contexts and whatnot. Now, when we want to know things, we may want to know many different things. So it's unreasonable to expect to have one model that's going to represent all the information in a form and shape that's useful for everyone that can potentially ask for information. Just to give you an example, let's say, again, back to the invoice system, right? You may want to have a read model that returns just Java objects with, invoice numbers, right, for listing purposes. But you may have another model that returns PDF files for invoices to be printed out. Or you may have another model that returns, JSON data for integration purposes. It may be just the invoice number and the value. In some cases, it may be all the positions. It may be a view that shows you the summary of all invoices per month or per week, right? All these potential use cases of like how I want to use data, it's next to impossible to represent them with a single model and be performant and be a good fit. But then you have to, because those are only read operations. They don't change anything ever. So there's a zero chance for you breaking something, right? So you can have multiple models. You can do a model for this, a model for that, and then you optimize your system to perform depends on what your needs are, without having to worry that if I add this to my model or I create new model, someone's gonna be using it and is gonna insert something in my database and the whole thing's gonna explode, right? Because this is read only. So you have one model on the right side where you guard things, you make changes, and that's the thing that is the most important. And then on the read side, you do whatever it takes for your application to become performant or be better optimized. But now we have a problem. We have multiple models, at minimum two, right? One on the right and one on the read. And ideally, there can be like, I don't know, tens or hundreds reads of models. So how do you sync them? How do you assure that your read models are synchronized with your write models? Well, wait. Did we do this with events? And we've been talking about events all the time. So guess what? We already have everything in place, right? If you consider that on the left to be your write model, or the event model, or the command model, and I have a typo there, the command model, and that be your query model, well, the idea of synchronizing those is already in place. We do this with events. We just send events. We have an event store that's a single source of truth. And then on this side, we build temporary storages that can represent whatever we want them to represent, right? An event can be new invoice was issued, right? And then 5 different models on the query side can update themselves. One would grab the PDF file, one would update the JSON records, the other would update the database and whatnot, right? It's still produced from the very same event. But from the overall system perspective, what happened is a new invoice was issued. That's it. Notification of a fact that has happened, right? So we have all this in place already to do CQRS, and then CQRS in this situation becomes trivial. So we talked about DDD, a brief, not a lot, but I mentioned DDD a few times. We talked about event sourcing, which is kind of the, let's say, most complex way of event-driven applications. And we talked about CQRS and how on this diagram, you basically see them all playing nice together. And that's what we called event-driven system at AxonIQ. That's what we think people should do when they say they build event-driven systems. And so we are on a mission to help the people who want to do this, do it better, faster, and more efficient. So we've been doing this for about 10 years now, I believe, or correct me someone if I'm wrong. We have some software components that basically help you do this. Starting with that box in the center, we have 2 products that actually serve that very purpose. They're both a message router and an event store. And that's Axon Server. Axon Server is a free open source, well, not technically open source and by like the official open source licenses, but you can use it for free. The only limitation, I believe, is you cannot clone it and make your own version of it, or like redistribute it in a way under a different name. But other than that, it's pretty much open source. There is an enterprise version of it if you want to have more enterprise features and stuff. And AxonIQ Cloud is essentially Axon Server in the cloud managed by us. So if you don't want to put it on your infra, but just use it in the cloud, then you go for AxonIQ Cloud. So essentially what this does is 2 things. It routes messages between components, and it stores events efficiently. Like, it is a fully efficient event store that meets all the requirements that we were talking about earlier. And now you would say, well, that's all I need. Let's go do some stuff. Because that's what we do when we draw diagrams like this. And that's my favorite part on such diagrams are, and this is not working here, are those arrows, right? And I've seen tons of diagrams in my life, and every time I'm making fun of the arrows, because this is where we make this assumption that we have this important component and this is another important component, and we just draw an arrow in between, and automatically they start talking to each other, right? And then you start implementing that, and only after that you realize how much effort it is to implement an arrow, right? Yeah, when you start implementing arrows, then you feel the real pain. So we want to help you reduce that pain, and that is the other product that we have is Axon Framework, which basically makes implementing those arrows trivial. So what it gives you the ability to have, let's start with the consumer. So consumers can subscribe to things by just annotating methods. They can basically just say, I can handle this type of event, or I can handle this type of command, or I can respond to this type of queries, right? And then they just register themselves, right? On the command side, on the producer side, you have gateways and buses. You have a command gateway, a query gateway, and an event gateway. And what you do from your component is basically the same thing what we drive on a diagram. You said send event, publish event, send command, send query, right? And that's it. You send, well, you can do it synchronously or asynchronously. You can do send and wait, or you can just send it and then it's going to come back in different channels, whatnot. There are tons of optimizations there, but that's the core idea, is that the abstraction is raised to the level where you actually use it the way you see it on the diagram. As a component, I'm sending a command. As a component, I'm publishing an event, right? Or I'm sending a query. And then someone is registered to handle this and send a response back. So combining those two will, for as long as you obviously use Java or a JVM language, because the Axon framework is currently implemented in Java, and surprisingly, a lot of people recently use it with Kotlin. So I would assume, I think it's safe to assume that pretty much with any JVM language you're okay with using it. Rumors has it there is something going on in the .NET space. That's as much as I can tell for now. But yeah, if you're in the Java land, you pretty much in a good hands. That all this stuff is taken care of for you by the software that we have. Of course, Axon framework is open source. It's like completely open source framework. You can use it without paying anything. You can clone it. You can do whatever you want with it. So I'm just going to give you the links here. The presentation is also online. So if you want to take pictures or if you want to find it online later on. Essentially, we have this developer portal. If you go to developer.axonic.io, all the information about products is there. So I'm not going to bother you with marketing stuff here. I'm just going to give you a few more links in case any of the things that I mentioned here today is something that you want to explore more. We have Axonic Academy, something started last year, and we already have quite a few courses there. That's an online learning e-learning platform. We have some courses that are conceptual about domain-driven design, event sourcing, and CQRS that are free. And we have courses about the products that are not free, but very affordable. And I think right now we still have 50% discount on pretty much all the courses. So if you want to learn more details about how things work, go check it out. The Discuss platform is where you can join us and our community and discuss pretty much anything related to those concepts or the products. And I mean, obviously, if you go there, you'll see a lot of people are using it as a problem-solving thing, like, hey, I have this issue, blah, blah, blah. But we do have dedicated channels where we discuss architecture and discuss whether or not it's a good idea to design things in this way or that way. So feel free to just stop by, and if you are in doubt, just drop a message and say, hey, I'm thinking about this. I don't know if it's a good idea. Someone with more experience would probably be more than happy to talk to you about it. Axonic initializer for any Spring fans here. If you know Spring Start thing that generates projects for you, well, that's the same thing, but for Axonic products. So just quick jump start if you want to try things out. And last and not least, my colleague Sarah Tori is doing quite an interesting podcast. She's interviewing different people. Not a lot of people are my colleagues from Axonic, in full honesty, but she's also talking to some of the guys that I mentioned earlier, like Alberto Brandolini or Adam and others, other names in the industry. So if you are into podcasts, highly recommend listening to her episodes about exploring Axon. And that's pretty much all I have for today. And I really hope now to answer your questions. Thank you. Not everyone at the same time.
Just a second. Use this.
Yeah, you have been talking. Well, many thanks for the chat so far. And during the presentation, you have been talking about a component, and the component is the one that is sending the events to the event system, basically. And you said that we should be able to recover the state of a specific component directly from the event store. But can you please elaborate more or give some examples of what is for you a component? Because that's something I still do not understand.
Okay, so yeah, I deliberately use. So let me go back to that slide. I assume that's what you were referring to. So what is a well? I deliberately use the word component because it does not bound it to a specific meaning. So what we typically do with our stuff and with our customers. We typically don't talk about components, but we talk about aggregates because we suggest people to use domain-driven design. So when you have an aggregate in domain-driven design, it's essentially a form of encapsulation. That is a group of objects that exist together for a reason, right? You form a boundary within a group of objects, and that you treat that group of objects as a single thing with respect to changes. Right, that's a definition you will find in domain-driven design, right? So, if I were to do this talk in among a group of people that everyone's familiar with DDD, I would just use the term aggregate, and everyone would immediately understand what I'm talking about. Now, I'm using the word component because not everyone does DDD. Not everyone's familiar with that term, but essentially the concept is the same. It could be a single Java class. Right, a component could be a single Java class, or it can be a group of classes that logically, from business perspective, or state change perspective, are considered one thing. Like for example, just to make it a little bit more clear, that also depends on the context, right? Let's say I have an object that's a car, right? That could be one object and one Java class, a car, right? But it could also be a group of objects. It could be an engine, a steering wheel, tires, and blah, 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 right? So now there's a group of objects that all together represent a car, right? So now for me, from a consumer perspective, from a driver's perspective, a car is a car, right? I need to be able to drive my car. I don't say, I need to be able to open the door, start the engine, press the pedal. I think about the whole thing as a one thing, as a car. But that's my context as a user. Now, the very same object goes to a car mechanic, right? They need to do repair, right? Now, for them, it's not a car anymore. It's an engine, it's oil, it's tires, it's, So in their context, the unit of things that are considered a whole, it's different, right? And so it's really hard to explain this in a generic manner, right? In every system, that component would be something that makes sense in that domain space.
Okay, thank you.
Yeah, firstly, thanks a lot for the talk. It's quite interesting. So my question is regarding when you spoke about source of truth thing. So,
Okay.
So you had the two things where event source and I think event carried state, event sourcing and event carried state. And you said when you talk about event carried state, you said it could result in multiple source of truth per se. Did you understand that right? You said that because you carry the whole state and you say from order went from pending to cancelled or whatever, it could result that multiple consumers have.
You talking about
Yeah,
this?
this one. Yeah, okay. So I can't really see from here.
Yeah.
Carried state transfer.
Yeah,
So,
that's event carried state transfer.
Okay, so my question would be that, so you said this could be a problem. So could you give a bit more concrete example? Because whenever there's a state change, obviously they will get notified, right? So I don't see a...
If they are alive.
Okay. So, but if you are dead, then there is no source of truth for them.
So maybe I should update that slide to be more clear about it then. So normally event carried state transfer is basically all this is at the moment when things happen, is present and functioning properly, right? So you don't have anything in the middle here, right? Or yet at this point. Right? So you're talking directly. So you call that component and you say, here is the data, right? And that only works if that component is alive and functioning properly at that moment.
Okay.
But now, you could be calling a component that's temporarily unavailable. There could be a network failure.
Okay.
Or there could be a failure on the component itself. There could be they could be overloaded and then return. And then now, you from a producer may or may not have accounted a situation that that message is not delivered. Okay. Now, you may do retries, but you may not. And you may, even if you do retries, you typically will do it for a certain period of time and then you give up, right? Because you cannot retry forever, right? So there's tons of things that can go wrong and that component all of a sudden, like, it's been gone for a day and then no one noticed and then it comes back, right? And start receiving other notifications after that, right? So now the state of these two is different, right? But unless you have a very sufficient monitoring system in place, you would be not able to tell what went wrong and when, right? That's why these days, if you and I assume all of you who do event-driven systems these days, probably the biggest emphasis is on monitoring and tracing, right? That's because to prevent situations like this, because that's what's the biggest disaster in event-driven system. In when everything is synchronous and in the same thread, it's easy. Exception, boom, logs, right. In these situations, it may be hours and days and weeks and months before you discover that something went wrong some time ago, right?
Yeah, thanks. I have another question.
Yeah, go ahead.
Not related to this. So I haven't really used Axon, but a little bit I'm familiar with it. And then a couple of years ago, we were doing hexagonal architecture. And so one of the things we kind of couldn't really understand is in hexagonal, in your own domain, you kind of have to avoid using any external dependency in your code. So your domain code should be completely clear of any sort of dependencies. But if you are using with CQRS, and then if you're dependent on Axon, you have these annotations. I don't remember the names of the annotations to say, like, this is my domain for query or this sort of things. How do you handle this? I mean, if you are working with Axon framework, do you say, like, okay, this is part of my domain and I can assume it and then put it in my domain code and annotate classes saying, like, okay, this is a query model class, this is a command model class of sorts, or is there a better way to do this?
So we get those kind of calls for a deep dive into a particular architecture because it's really hard to answer this as a general purpose. So, well, I'll try, but that's going to sound like I'm avoiding the question, which I'm not. I'm just trying to figure out how to generalize something that is relatively specific. So, in domain-driven design in general, you have two ways to introduce boundaries. One is aggregates. So aggregates are those components that we just talked about, right? So an aggregate represents a group of objects that are a unified thing in terms of changes. The other thing that you have in domain-driven design is bounded context. And so bounded context allows you to define a common meaning of something. Right? So I'm just going to use the car example again. So in the context of me, the car user, the word car has a specific meaning. And we all, as users, we all in that context agree that when we say car, that's what we mean. Right? In the context of car mechanics, right, the same word car has a different meaning. Right? It's about parts, spare parts, and things like that, right? So that's different bounded context, right? And within that bounded context, the same word has different meaning, and so forth and so forth. So one of the biggest problems which causes things that you describe, I believe, is that we tend to think that just because we use a word, everyone understands the same thing, right? But when you design with domain-driven design, that's the fundamental thing, to define your bounded context and say, with this context, it means this. With that context, it means that. And then you have the mapping between the contexts. So what Axon Framework typically does is it allows you to define both the objects within a context, right? And then the communication between contexts. And so what we typically suggest and advise people to do is to have what we call a cross-context event. So normally within context, you would want very detailed events, like this happened, this happened, this happened, because you're talking to a tiny little group that probably is interested in every tiny detail, right? But say, for example, with the same with invoices, right? You know, if a new invoice is issued, probably all the accountants need to know immediately, right? But when you talk in the context of company management, directors and whatnot, they probably want a weekly summary and of the number of invoices of something. So then it makes no sense to send an event to the context of board of the directors for every invoice, right? Because the only thing they would use it is to calculate an amount that they're going to look at once a month, right? So what you would want to do is, in the accountant's context, have these events because they make sense, but then have one big event that you send once a month or once a week, or when something happened on every 1,000 invoices, whatever the business rules are. And then you just update that other context, and then whatever needs to happen in that other context happens in there. So those are the things that Axon Framework allows you to define, model, register, and operate. But it will not help you at all with the business logic. It's you. You have to decide what makes sense for that particular application, right? And then the reason for that is we don't want to make any assumptions, right, about things, right? We do the wiring, right, but you know the logic of the application.
Thank you.
Yeah.
Any other questions? Come on.
Okay, so there's another one, no?
I don't know. Any other questions?
No other questions? They're all, you can't see beer and pizza in their eyes
Yeah,
already.
well, it's but you need to wait a little bit more for that. So thank you, Milen. Thank you for sharing with us all these stories about events and concepts and so on. So what we are going to do now is, after the talk, we are going to raffle something, but let's get anyone knows about JVC and Conf?